Hello everyone, this is Miss A. This is our video if you need extra help on any Geometry Chapter 2 practice test problems. Again, today we're doing things a little bit differently. Now you're looking at your specific worksheet and you're going to see my guided notes and then try to do the even problems on your own. And if you get stuck on those guided notes, that's where I'm going to review them right now. So we're going to get started with number 1. If you notice, this is a vertical angle, and what we know about vertical angles is that they are equal to each other. Okay, so each time you see angles that are across from each other, you're just going to set it up equal. Okay, line down the equal sign. You're going to subtract 21 to both sides. Okay, bring down 3x. 66 minus 21 is 45. You're going to divide, and x is equal to 15. That is going to be answer C. So go ahead and try number 2 on your own. Okay. Next problem was number 3. This is complementary angles. One thing that we know about complementary angles is that they're going to add up to 180. Okay. So when you see degrees that are right next to each other, this is going to be adding up to 180 degrees. So I'm going to go ahead and add those up. And I'm going to make equal to 180. So our big notice, okay, we're going to add, make it equal to 180. So, and since we're just solving for x, I don't need to do any other extra steps besides this. So I'm going to combine like terms. This is 9x, and this is 72. Okay. I'm going to subtract 72 to both sides. 9x is equal to 108. Divide by 9. X is equal to 12. So that is going to be C. X is equal to 12. Okay, go ahead and try 4 on your own. Number 5. Okay, big notice. So in the classwork, we didn't really work with angle bisectors, so we added it to 90. However, for the test, we are given the word angle bisector. And remember, bisector means cuts exactly in half. So this ray cuts this angle exactly in half. I know that these are going to be equal to each other. So big notice on the test, you just need to make these equal to each other. Okay, and then again, just solving for x. Line down the equal sign. Between my x's, I'm going to subtract the smaller one. 6 minus 3 is 3x, and bring down the 9. Divide 3 to both sides, and x is equal to 3. Okay, again, big notice, these are just going to be equal. You are going to go ahead and try number 6 on your own. We're going to move on to number 7. Okay. This one I'm going to do 3, and then you need to do 3 on your own. So this is why I kind of put a little scribbly line on your worksheet. So we are figuring out, is this transitive, symmetric, or reflexive? Okay. Quick review. Reflexive, that's when they're equal. Symmetric, this is where we switch. And transitive, this is where we cross off what they have the same. So let's look at example 7, okay? MN is congruent to PQ, and PQ is equal to RS. Then MN is congruent to RS. I have a lot of stuff going on, so I know this is not reflexive. Nothing is equal to each other. Here, if I switch it around, it doesn't really work out. So let's check if it's transitive. I have PQ that's the same. Again, crossing off what they have the same. And whatever's left over is going to be equal. So MN should be equal to RS. That checks out. So this is going to be transitive property. This example, I need to ask myself, is it equal, switched, or am I crossing off anything? Here, these are the exact same, so this is reflexive. And then lastly, for number 9, I noticed they just switched the order. This is symmetric. So you're going to get 3 problems similar to this on your test as well. Okay, I'm going to go over number 13 now. This is a literal equation. On the left, you're just solving for x. And on the right, you are giving what property it is. What step are you taking? So they give us -6 plus 9 is equal to 15. So I'm going to go ahead and start. Line down the equal sign. What would I do to get x by itself? Well, I know I'm going to divide -6 out of the way, but before I divide, I need to get rid of this 9. And the opposite of a positive 9 is going to be negative 9. Okay, so whatever I have left over, my new equation is going to be rewritten in this nice little box. 15 minus 9, I'm going to do my calculator. I'm going to look up my notes real quick. And that is going to be positive 6. That was what we subtracted. So this is subtraction property of equality, but I'm just going to keep it short. I'm going to put subtraction property. And then lastly, how to get x by itself? I'm going to divide negative 6 to each side. Okay, positive divided by a negative is negative. So that's going to be negative, and then 6 divided by 6 is 1. And this was an example of division property. Okay, again, here you're solving for x. Here you're writing what specific step that is. Okay, you're going to try 14 on your own. Okay, 15 is going to be a long one. We did an example of this in 2.5 day 1 classwork. We have another literal equation, and we kind of want to manipulate our letters around. Okay, we're not solving for anything. We want to move our equation. So for example, here we want to move our equation so b is by itself. Okay, so they do all the steps for us. We just need to write what property it is. We have the list of all the properties here listed if you need it. You're not going to use all of them. So starting here, I'm given that a is equal to bh divided by 2. Okay, what do I notice? I notice that a got the 2, and I was able to get rid of this fraction. Okay, so how do I get rid of a fraction? I multiply by the denominator. So I multiply by 2 to both sides. Okay, that crosses off. And that becomes this new equation. 2a is equal to bh. This was multiplication property. Okay, from here to here, what do I notice? I got b by itself. Okay, over here, h became the denominator in the fraction. So if these are kind of squished together, they're multiplying. Opposite of multiply is divide. So to get b by itself, I'm going to divide h to both sides. Okay. H is crossed off, and this becomes a new fraction. And that was division property. Okay, lastly, all I did was switch the order. That was symmetric property. Okay, the question is not done yet. This is a 2-part. I have part A and part B. So don't forget that while you're taking the test, don't forget to do this second part. Okay. So, now that we got b by itself, we're going to use this equation. It's rewritten for us here. They want us to find the base in feet, and we're given our h, which is height. Our height is 15, and our area is 45. So now that I have all the components I need for this equation, I'm going to rewrite it. Okay, 2 times a, my area was 45, divided by my h, which we said was 15. I'm going to multiply the top first, the numerator. 2 times 45 will give me 90. And then bring down the denominator, which was divided by 15. And 90 divided by 15, according to my calculator, is 6. So my missing base is equal to 6 feet. Okay, that is that problem. Okay, so go ahead and try 16 on your own. 16 is going to look similar to it. Different steps. And don't forget right here, you're plugging in, okay? You're plugging in length. You're plugging in perimeter. Okay, 17. You are going to be given one proof on the exam. So I'm going to go over how one possible proof may look like. You're going to try 18 on your own afterwards, okay? They are going to look very different. So make sure that you feel prepared by looking at 17 and 18. Okay, so let's look at number 17. Always start off, my first word is given. Okay, so even if you don't understand anything of proofs, please at least write given, and that'll be at least 1 point that you can receive on the exam. So we are given that measure angle 1 is equal to measure angle 3. Okay, for number 2, we have measure angle 2 is measure angle 2. Okay, using all my properties, I know that when I have something that's equal, guess what? This is called reflexive property. Okay, so if you notice that one side of the equal sign is equal to the other, know right away this is reflexive. Let's look at number 3. So looking at our statement, our little equation from 1, okay, it suddenly got bigger, okay? It was originally just measure angle 1 is equal to measure angle 3, but now we included more stuff, okay? What's another way to say included? What did we have here? This is addition property. So from our original equation in step 1, we added angle 2 to both sides, okay? And then this is, again, addition property, okay? What happened here? So let's look at our little diagram, okay? I'm going to highlight so that maybe it can help. I added measure angle 1 with measure angle 2, and that gave me measure angle AEC. So we saw this in chapter 1. We saw this in Monday's classwork with 2.6 day 2. What is it called when I add two angles and it's equal to the total? This is called angle addition postulate. Again, when you add two angles and it's equal to the total. Okay, so that's what I did here. I added the pink and the blue, and it gave me this total, which was the orange. Okay, same thing here. I added 3 and 2, and it gave me BED. I'm not going to highlight it, but we kind of get the idea. This is also angle addition postulate. Okay, so let's look at what we have. Okay, so we know that we have this equation, we have this equation, and they end up being equal. So if you notice back at our original, or second, equation that we made, okay, measure angle 1 plus measure angle 2, we know can also be written as measure angle AEC. Measure angle 3 plus measure angle 2 can also be written as measure angle BED. So what I did is I grabbed this equation and I substituted in the new angles we found from the angle addition postulate. Okay, again, I grabbed this equation, measure angle 1 plus measure angle 2, and I subbed in AEC. Measure angle 3 plus measure angle 2, again, I subbed in BED. So this is an example of substitution property. Okay, these are a little bit trickier than the ones that we did in class because now we're looking throughout all the statements. It's not necessarily you looking at the statement above. You kind of have to glance at all of them and figure out what are they doing. Okay, I'm going to go over number 18 in case you are completely lost. So I'll give you a moment right now if you need to pause the video. Try 18 on your own, and then once you get stuck, then rewatch the video, hit play again, and then you can see what you got wrong or what you did right. So try 18 on your own, and then if you need extra guidance, watch the rest of this video. So first reason should always be given. Again, easy point. So let's look at number 2. I have wx plus xy is equal to wy. This is an example of, okay, instead of angle addition postulate, we're working with segments. This is an example of segment addition postulate where I can add the two segments and it's going to give me the total. So this is what they did here. Okay, they used segment addition postulate. Okay, exact same thing. They added xy plus yz to get the total xz. I'm not going to highlight it, but it's the same idea. This is segment addition postulate. Okay. So wx plus xy is equal to xy plus yz. So they did also here substitution property. Okay, and I'm going to break it down on how they did that. So this was our equation from the beginning. We know what y is and we know what xz is. So instead of writing wy, we're going to replace it with this whole chunk, wx plus xy. Again, replacing, substitute means replace. So instead of putting wy, what's in the fields now? Remember, think about substitution as sports. You're subbing in players. So instead of wy, we now have wx plus xy. Okay? For here, xz, we're going to substitute, and we're going to put xy plus yz. That's how we were able to create this longer equation. And then after that, okay, I got rid of some stuff. What do they both have in common? Okay, we're going to continue on now to the bottom. Okay, seems like it's frozen. Hopefully that fixed it. Okay, we are doing the bottom half now. We have substitution property. Okay, what am I going to substitute? I know what AB is, so instead of AB, I'm going to put 5. So 5 plus x is equal to 22. Okay, symmetric, I'm going to switch the order. Y is equal to 5x minus 3. Go ahead and try 20 and 22 on your own, and you should be good.